Hi, I'm Malachi Grubb, CEO and engineer of Elite Automation. So today we're going to be setting up some Mac valves over Ethernet. So instead of using a hardwired connection, we're going to be using the Ethernet protocol to communicate to these things. This is kind of the future of automation and where things are going. Everything's going to be over Ethernet or a Profinet or Modbus or IO link, some type of communication protocol. So in this video, what we're going to do is show you the step-by-step processes to get these things set up and communicating. We're going to be using some AOIs, loading in the tag names, and then adding the tags to the AOIs and whatnot. So we'll go ahead and take you guys through that process. There will be a link down in the description below that will have the different AOIs and things you'll need to be able to set these up. So if you don't already have those, that could be a huge value add because you don't have to go searching around online to find them. Hopefully these will work out for the particular model that you have. All right, so let's go ahead and jump on the computer and start getting this thing set up. So one thing we'll have to start off with, and this is what we start off with every device pretty much, is either going to a factory reset or getting to a point where we can give this thing an IP address. So we're going to go ahead and open up ipconfig. Here's our Mac valve folder, by the way. With this Mac valve folder, you can come in here, and this will be the one you have a link to down in the description. Here's the setup documentation for giving this thing an IP address. So this is essentially just the IP address configuration part of the documentation. There's actually a very good set of videos that I'll link down in the description that Mac has done. These videos are actually way better and way more in detail than this particular video here, but that video is also like 2 hours long with all the different videos that they have within the lesson. But we plan to make this one much quicker and kind of get straight to the point and just bust this process out in a timely manner. So we opened up our IP config right here. We're going to go ahead and run a scan on this. As you can see, we got an address back as 192.168.0.26. The default IP address for this thing should be 192.168.1.25. We've actually already changed this at some point in time, so I just want to let you guys know that, and out of the box, you should be able to use that default IP address to get onto this thing. If not, you'll click scan. Your Mac valve should automatically just pop up. It'll say Mac, and then you'll have your address right here. Just verify your addresses match up. Now, we're utilizing this on a network card that has nothing else on the network, so it's just the Mac valve and our network card. Now, this is the way I always advise setting up devices, because if not, you can really run into some issues with having a bunch of other stuff on the network or writing an IP address of something you shouldn't be writing an IP address to, so just keep that in mind. We should not really need to do much into here. Just click into this, and as you can see, we'll just go ahead and change this to a 25, enter it, and just give it a second, maybe do a scan again. It changed the IP address to a 25. It seems like newer devices are getting much easier to set up. I know in the past, like, it seemed like you could give things like a boot P address and just like keep trying, and it would take multiple tries at it before it would actually accept like an IP address. So things are just getting overall much easier to set up over time, I think. So we're going to go ahead and open up our network adapter, open up network sharings, change adapter settings, and then right here, we'll go into our properties. And then we want to go to our Ethernet protocol version 4. And then you just want to make sure that this IP address is set to be within the same network that you just set your IP address for your Mac valves. And so I like to do this process and verify we have communication prior to putting this thing on the network. So, okay, the IP address looks good here. Another little trick that I do is I right click, I go status. So status will, status and then details. Then that will give you the ability to see what the exact IP address is set at. I've ran into instances here and there where this IP address is not the same as what's set in the settings. And so basically you just go back into the settings and do it again, and then generally that fixes the issue. But like I said, I've ran into issues with that, so just something to keep in mind. So now we'll go ahead and open up our web browser. We'll type in our 192.168.0.25 is what we just set it at. Boom. Here we are on the web configuration. So within this web configuration, there's a couple things that I wanted to point out real quick. One thing that I would say is very important is these module types. So with these module types, you'll need to know this information for whenever you go to set this stuff up inside the PLC. because whenever you go to set up your PLC side of things, if you have any of these out of order, then you're going to end up with some type of conflict, and you're not going to be able to communicate to the Mac valves or any of their I/O modules. All right, so from here, I just wanted to dive into this user interface just a little bit. I want to keep this part fast. Like I said, I want to get you online, up and running as quick as possible, so you can do your own research if you have one of these devices as far as just playing around with it and seeing its capabilities. But there are some key features that I want to point out. One, the status is very important, because this really helps whenever you're going to set this up on your network. This will let you know if everything is online and working correctly. So just keep that in mind. You want to have this. You want to have all these things to be in their proper running state. You want the things to be true that are supposed to be true. You want things to be false that are supposed to be false. And you can just kind of come through this. And some of them are just very explanatory. Like, are you running? Yes or no. And as we go through this process, we probably will jump back into here again to see if everything is up and running the way it should be. We're going to go ahead and do a factory reset. So that way we're starting off with this thing at the very beginning stage as if it just came out of the box. So just keep in mind, whenever we do this, it's highly likely it's going to kick us off of the web browser, because it's probably going to go back to the 192.168.1.25 versus the 0.25 right here. As you can see, when we did our factory reset, it went ahead and it completely wiped out the IP address. So it doesn't even have a factory default IP address in it right now. So what we'll go ahead and do is just assign it that IP address. So we're going to come in here, turn off our DHCP. We're going to give it the IP address of the 192.168.1.25. Subnet mask 255.0. That should do it. Boom. It looks like we have an IP address. Let's make sure we're seeing it on the web browser. Boom. We're back alive. As you can see on our status, it's changed a little bit because now it hasn't been given any configurations from like the PLC and whatnot. So the first thing we're going to do now that we're in the Allen Bradley software is we're going to go to our tools. We're going to go to our EDS hardware and installation tools. And we're going to import this EDS file. So register EDS file. Next. We're going to register a single EDS file. We're going to browse for it. We know we have our file stored on our desktop for the Mac valves. So we're going to go inside the Mac valves folder. We're just going to keep digging down till we find this .eds file. Basically, an EDS file for this particular instance, it's basically going to give us the ability to add this to our Ethernet network. So okay it, next. As you can see, it found it. It recognized some the items within it. Finish. So basically, it gives us the ability to come in here, go new module, and then this will pop up. And now we can just type in Mac valve right here, and boom, we're good to go. You can create that. If you didn't have this, you'd have to set up a generic Ethernet IP module, and then there'd be a ton more configuration on that side of things. If you didn't have this, then you'd have to do a generic Ethernet IP module, and depending on how good the documentation is, it could kind of be a pain to do the generic Ethernet IP way. To be honest, I've probably done more generic Ethernet IP than I've done of anything else, and it is much more complex. So we're going to go ahead and create this. Okay, whenever you come in here to create this, we're going to give this a name. So our name is going to be, we're going to go with valves. And the only reason I'm going to go with valves is because that's what they used in the Mac valve demonstration. So if you happen to go into the Mac valve video to watch their version of this, things will line up a little bit better. So we're going to go ahead and give it the IP address of 192.168.0.25. And then we'll just come in here. We'll give it a description. We'll say Mac valves, just so there's not any confusion. So as you can see, it just added it into our Ethernet drop-down right here. We're going to close this out. And I'm going to go ahead and download this to the controller. All right, so now that we downloaded this to the controller, you can see right here you have your IOOK. That signifies that our Ethernet module is actually talking to our MAC valves. So you know there's a general communication going on in the background on the Ethernet. Now this does not necessarily mean that the PLC is being able to talk to your inputs and outputs. There still has to be the configuration set up on the AOI side of things. So we're going to open up our assets. We're going to go to add-on instructions, import add-on instructions. So we're going to go ahead and OK it. As you can see, we have a few of these add-on instructions already added. Basically, we're just going to go ahead and go through the process of adding every single one of these. That way, for some odd reason, if somewhere down the road a different module gets added on, the module will already be here in the PLC logic. Some people advise against it because now you have an add-on instruction that's not being used. For something like this, I think it makes sense. You don't have maintenance or somebody come along later down the road and have to put in a ton of work to get this done. Or if, for us, being systems integrators, we're probably going to be the one adding modules and whatnot. It'll be a lot easier and simpler for us to go ahead and have this stuff pre-installed versus having to do it on site. All right, so we went ahead and added all the add-on instructions just because it makes sense to kind of future-proof things if we ever add a module into the future, whether it be prior to the completion of the install or whether it be somewhere down the road. Maybe it's maintenance. We could potentially walk them through it on the phone versus them having to get these add-on instructions. Being that we're creating this video and we are adding a link down below, that'll make it a lot easier for people because if we didn't do this and you're not watching this video, then you're going to have to be searching for these add-on instructions online somewhere. And, you know, that could just be kind of complicated. Maybe somebody just can't find them, even though it could be super easy to find them. But, you know, or it may take a certain skill set to find something like these add-on instructions. Whoever's trying to add the hardware may not have the capability of finding these add-on instructions. So, you know, luckily they're in our video description below, and also it just makes sense for us to go ahead and add them on here. Go ahead and add all of them here, even though we're actually only going to utilize a few of these. I think the only ones we need are configure modules, digital I/O, Power Plus, and solenoids. So we are using quite a bit of them. We're using 4 of the 5 of them, and I think the SCP is being utilized in the background as well. So we're going to go ahead and open up the CSV file that you can find in that folder as well. We need to change the tag names to match the Ethernet module that we had installed. So right here where it says MAC valve, we need to do a Control F, which is a find, and then we're going to click replace. So what we want to do here is we want to copy this MAC underscore valves or valve, and what we want to do is we want to replace it with just valves, because valves is what we used for our Ethernet driver. And now you just need to make sure that these correlate, so that way this tag name will line up with your actual tags inside the processor, and then this will give you descriptions for all the tags that these AOIs have automatically created. So it said OK. As you can see, it replaced all the MAC valves with the valves here, and we're going to save this. All right, so to go ahead and import that CSV file, we need to go to Tools. So to import that CSV file, we need to go offline, go to our Tools, Import, Tags, Logics, and Comment. All right, and so here we will go to our file location where we have this stored at. I know I moved quickly, but this is where we have our file stored at. Here's the tag names that I just created. We're going to click that and then click Import. Then you can come down here and you'll see complete. If there's any errors or if there's any warnings. If you do have any errors or warnings, it may kick out and say everything was reverted back. So it says everything was imported, nothing was kicked back. It'll basically say that it failed somewhere within this this error list here. So now that we have those plugged in, we're going to keep chugging forward. Now, you could keep going back and checking some of this stuff, but I just know from past experience, as long as you verify, the thing's imported fine, you don't need to go and check every little thing. So now we're going to come up here to our main program, main routine. I'm going to start plugging in the different add-on instructions that I think we'll need. So I know we're going to need the configure modules. We're going to need the Power Plus module. We're going to need the solenoid valves over here, solenoid control. By the way, I'm just organizing things as I see fit. I'm putting these solenoid controls up at the top because I'm going to have these laid out the way they physically are laid out, the way the hardware is physically laid out. So to the far right side, you have your solenoids, which your solenoid controls will control those. Your configure modules will be your actual Ethernet adapter, your Ethernet module, your communication module, the hardware module that is. I don't want to get you confused with the software module that's over here. Then we will have the Power Plus module, which is the first one to the left of the Ethernet module. So we're working from right to left with this on the ladder logic here. So this is basically going to be an output. That's all this is an output card. We need to do one more. And then this one's going to be our digital I/O. So now we have all four of them laid out. These are all four of the physical hardware devices that we have. So in the software, you see, and I correlated everything from right to left. So on the top, you've seen this is going to be solenoid control. Then right here, this is going to be the configure block. And so the configure block is going to be to set up the Ethernet for the Ethernet module. Then we have the next module down in the software, or next module to the left, which would be the Power Plus. So these are all outputs. This does have auxiliary power to this module, so that way you can fuse this separately or run it off a completely different power supply if you'd like. And then there is the configurable IOs, which will just be your digital IO. And there's 4 different versions, I believe, of this configurable IO in the configuration settings. And basically, all that is whether you have the first 4 as inputs, and then the first 8 as inputs, and the second 8. So we have a total of 16. So with the 4 different configurations, it's basically whether the first 8 are going to be input or output, whether the second 8 are going to be input or output, and then whether this device is set up as PNP or NPN. And there's dip switches inside of this right here where you can open that up and look in there, or there's also a place in the web browser where you can look at this as well, and it will tell you how it's currently configured. So hopefully seeing like the layout of how these are laying out and seeing the software side of things, it'll make sense how we go about configuring these different modules and setting up the AOI instructions. These ones right here will need to run constantly. The configuration one, the configuration module right here, needs to be a toggled type of instruction. Now, you can do one or two things here. You can either put a toggle here and or a first scan bit. So on the first scan bit, whenever the processor has its power cycled, whenever it comes back alive, it'll fire this rung. This really comes in handy whenever, like, say, for instance, if the Ethernet module ever goes bad, and then you just throw a new one in there, you can just throw your new module in there, power cycle your PLC, and then it'll automatically shove the configuration to the new Ethernet module. So that does come in handy, but if somebody ever does come in here and change anything, and then somebody power cycles the PLC, you might run into issues with it overriding some stuff. So some people are with it, some people are against it. We're just going to put in a simple generic toggle bit here. We're going to need to create this tag. So new tag. We want it to be a Boolean. It's automatically added as a Boolean. Create. So then we're going to come over here. We're going to call this valve config AOI. Now you can just basically create this name to be whatever name that you want and whatever name that you remember. Now for this one, for these next three here, these ones do matter. So this one you want to call out your valve and then C dot data. Go ahead and enter. And then what we're going to do is we're going to drag this one down to the next three. And we're just going to change this one right here is going to be valve I dot data. And then the last one is going to be valve O dot data. And you see it auto fills it in, which basically implies that we have the correct tag. Now here with your module selection. Alright guys, new day, but we're going to continue on with this video here. We left off yesterday with the configuration of the AOI modules. One thing you missed out that I just did here is I right clicked and I created this new tag. You'll see me do it on one of the next ones. But whenever you create this new tag, it gives you this description. And what this description is it calls out the number that is related to the type of module that you have. So in your module selection right here, this would be like your module 1. So the first left module to the Ethernet port, as you've seen in the hardware a second ago. So if you look at your hardware and you look at your Ethernet module, the first one to the left is your module 1. Your next one to the left is your module 2. So with that being said, in our instance, we started off with a Power Plus module. That's our first left module. So on a Power Plus, we're looking at an 11. So on our module 1 selection, we're going to put an 11 in here. Now, just to point this out one more time, right here where it says 11 is equal to Power Plus. You can look up in the documentation if you're not positive what module you have, but there's not really a ton of different modules. There's the Power Plus ones, there's analog modules, there's analog current modules. There's just not really a ton of different modules. This is all one module. This is all the digital I/O module, and then just based on what configuration you have of that module. But depending on how you have the dip switches configured will change what value you put in here for this configuration. So for ours, I believe we have ours signed up as an input, PNP, output. So I believe, if I'm not mistaken, it's number 4 right here. Input, PNP, output. So we're going to plug a 4 in right here. And then now this one should be good to go. Now we're going to come up here to our solenoid control. Now when it comes to this tag name for your AOI, it really doesn't matter. You don't really utilize this. This is kind of just utilized in the background. But I do put something about AOI in it, so if we do see it somewhere else, or it does happen to be used in the logic, you know what it's coming from. As far as your input and output data, we're just going to copy the same input and output data from the other instruction that we made. So it's the same tag name. Now this one is kind of important, the configure tag name. And the reason why that is important is because this is the actual tag that you'll be utilizing in your logic. We'll just call this one solenoid valve. New tag, create tag. It's automatically going to assign it a data type right here. And this is a UDT data type created by the AOI fault reset. We're just gonna go ahead and just or reset fault. We're just gonna just say reset fault. We're just gonna repeat that. Now with reset fault, I'm actually gonna utilize this one on all of them throughout here. So Control C. I'm gonna new fault, Boolean, create it. Okay. And we're going to go ahead and just, while I have that copied and paste, we're going to paste it in all of these right here. So reset fault. This one doesn't have a reset fault, it doesn't look like. So we'll come back up here. We're just going to repeat this one too. Fault last message. And if you want to get creative, you could create a UDT and call it fault, or call it AOI fault, or Mac valve fault. And then you could put these different tag names inside of a UDT. You just have to pay attention that whenever you create this, when you say new, that you're using the right type of data type. See how this one created a data type string? So if you created this in a UDT, you could essentially have these all as a UDT named fault, and then it could be fault dot last message. So we'll create that. We're just going to repeat this one again. And I'm just kind of going through and repeating these just for the sake of making the video quicker. To be honest, if we was doing an actual application, I probably would go ahead and create a UDT. And sometimes I'll get halfway through configuring something like this, and then I'll decide, you know what, I think we are going to make this a UDT. Because anything that we look at that I think will make our programming more uniform and more patternized, we'll take the extra initiative to do so. I just want to point out that all these have different data types. So just keep that in mind whenever you're doing something like an AOI or any type of instruction in general. So we went back through here and verified that everything has been created. Now that everything has been created within this instruction or this AOI, now our rung is good. It is satisfied. We're going to go ahead and come down here to the next AOI. We're just going to call this one Power Plus AOI. Do the same thing as we did up there. Drag these input and output data down. Then we're going to have this configure tag name. And remember, this one is kind of important. So, we can call it Power Plus. We're going to go ahead and call it Power Plus. Power Plus outs. Just to kind of imply that these are outputs. Or we'll just do, yeah, it's fine, outs. And then module location. Now this is new. We didn't see this on the last one. And the reason why we didn't see this on the last AOI that we just did is because it's the solenoids to the right. And the solenoids to the right are always to the right on the Mac valve, so they don't need to be assigned. The Mac valve already knows that that's going to be there, and there cannot be any other module to the right side of the Ethernet module. So this one's going to be a 1. We'll go ahead and put a 2 into the next one. And now we just got to go through here and create all these new tags. Those will already be created. This one needs to be created. It's going to automatically assign its data type. Boom, the rung is good. Rung is satisfied. Now we're going to go digital IO. AOI. Remember, that one right there is not as important. We're going to drag and drop from above for our input and output data. And we just know this because of what's sitting right here next to it. And then I believe the next one down needs to be just the config. Just like that. And then our tag name needs to be tag name needs to be something that we can remember. So digital IO Now, one thing you could do right here with these configuration names, the configure tag name, you could make these to like where they're physically located. You could make these like solenoid bank 1, module 1, solenoid bank 1, module 2, to kind of represent its physical location of where it is at on the solenoid bank itself. But whatever works best for you, whatever's going to help you remember, and maybe even make sense to create some type of UDT to store these in. So we'll go through here and say new. Boom. It looks like it accepted it. So as of right now, nothing's live. We haven't downloaded this back to the processor yet. Alright, so now we're going to go ahead and download this to the controller real quick. So this is the first time we're downloading to the controller since we added all these AOI instructions and configured our AOIs. So it's plausible that we may get some type of kickback, and if we do, it'll probably come up here in these errors right here. If we don't get any type of kickback, hopefully we'll be online and be communicating. In the meantime, while that's downloading, one thing I wanted to show you is we are plugged in and connected from the PLC to the Mac valve system. You can see right here it says running, it says true. We're operational here, which basically just means that we don't have any faults or any major errors going on. You want to go and remote run. Alright, looks like everything there came back fine. Those are constantly running. Now, what we have to do is we have to valve stack fault. I think we're going to need to shove this to it real quick. So we'll just toggle this bit off and then back on and then back off again. And now we'll also need this reset fault as well. Especially on the initial setup. Unless you do it like absolutely perfectly, then you won't need it. But alright, so run. So now we're just going to set a output. This output's going to be our reset fault. And then we're just going to put we'll just call this one like toggle 2. By the way, if I have to create multiple toggle bits like this, normally what I'll do is I'll just create a toggle and then I'll make it a dent and then I'll just do like toggle.0, toggle.1, toggle.2. Create it. That way you don't have like 1,000 of these toggles and you're sitting inside of your controller tags. So we're going to accept the edit. We'll go ahead and toggle that to see if we can get anything to reset. This one's definitely wanting a... This one right here is definitely wanting a power cycle. So we took it offline for a second, and now we're back online. The power cycle seemed to fix it. Part of this could be the fact that we have these AOIs online before we push the configuration. So it's essentially already trying to write to these AOIs constantly, yet we haven't even told it what it's going to be yet. And since they don't know what it's going to be, you're trying to write to something that may not even be there yet. So it looks like everything's enabled. I'm not seeing any major issues with it. Port 1 status. I think we're getting feedback from that. That should be a sensor right here. And that's what that is. So as you can see here in the PLC side of things, we are toggling. Now this is for the digital I/O. Now the reason why we have it go jump back and forth between the two bits is because the way this sensor's wired up. If it's off, it sends the signal to the I/O point 2. If it's on, it sends the signal to I/O point 1. So there you go. It looks like we're up and running. It looks like everything's working. So I'm going to come back into our web browser user interface and I'm going to check the status and show you guys that the status here, we have everything is running, our outputs are valid. All these things are now true. Right down here it says we're operational. And essentially, I just wanted to point those things out and just show you that these are some of the statuses you want to see to know that you're up and running in a good condition. If you all have any questions, if we still have these Mac valves on hand, or if we may end up going ahead and purchasing some, depending on the amount of questions we get asked on how to set these up and different things like that. And on top of that, we might start utilizing these as kind of a standard for our future projects. I do like the system. It's very smart. I like IO-Link a lot too, though. I like Ethernet IP stuff, so it'll be kind of hard to choose which one, because then you can go, you could go the IO-Link route and do a sub-D connector over IO-Link, and that's really cool. I've utilized that before as well. Hopefully you found this video super useful. If you have any thoughts, comments, questions, put them down in the comments below. If there's any other products that you'd like us to do videos over, or if you'd like us to come in and integrate a system like this for you guys, we can do that as well. Our primary focus is robotic cells and robotic cell applications. So any other technology that may be involved in a robot cell are technologies that we generally deal with, which is essentially everything. Almost every one of our applications has some other type of line tracking, vision, or combination of all of it. That's really what we like to focus on. It's really what we're good at, and hopefully we can keep bringing videos like this to you guys to help you in your experiences, and hopefully to help you guys through y'all's educational process and be able to explore these different devices, getting them set up and getting them online and running. That's kind of our objective here on this YouTube channel, is to inform you guys of different products, to help you get things set up, and to educate people within the industry, just getting into the industry, on how to work with these different hardware and these different softwares. So thank you guys. I really appreciate your time, and I'll catch y'all in the next one.